Dawn on the 22nd of June 1941 along the Bug River did not break clean and sharp for the men of Army Group Center. As the first gray light slid over the frontier fields, German grenadiers advancing past torn wire and abandoned trenches saw a low band of haze crawling over the ground. At first it looked like ordinary mist. Then it thickened into a veil that caught in throats and stung at eyes. Within minutes, patrol leaders realized that landmarks memorized from maps were fading. Church spires, tree clumps, even farmsteads were swallowed in a growing wall of whiteness. Veterans of Poland and France, used to modest engineer smoke screens over river crossings, felt a chill as this haze became something else. Machine gunners with MG-34s found their fields of fire dissolved into featureless gray. Some officers muttered about gas and ordered masks kept ready while runners went rearward, calling for reconnaissance teams. Others, recalling lectures on Soviet doctrine, pictured rifle regiments and anti-tank guns waiting unseen just beyond the screen. Yet no ambush came. Instead, in that artificial fog, Red Army units were withdrawing. Hidden by rocks, engineer smoke battalions spread across kilometers of front. In the opening hours of Barbarossa, as sectors of the battlefield vanished, the Wehrmacht saw that an enemy who could raise such walls of smoke might blind a modern army at will, and understanding how that capability rose would mean looking back to the origins of these vast screens in the decades before German soldiers watched entire horizons disappear behind Soviet smoke in 1941. The world's armies had already learned a bitter lesson. Industrial firepower made visibility a lethal vulnerability. After the trench campaigns of 1914 to 1918, when artillery spotters could direct massed guns onto any exposed movement, and machine gun teams cut down assaults the moment they were seen, theorists across Europe began treating concealment not as a convenience, but as a battlefield requirement. Smoke, once used in small pots and hand grenades, had proven capable of breaking an enemy's line of sight long enough for engineers to bridge craters, for infantry to cross killing grounds, and for attacking forces to disrupt observation posts that guided the vast barrages of modern guns. By the late 1930s, the British, Americans, and Soviets formalized these insights into doctrine. Manuals circulated that described smoke as a force multiplier, a tool that could degrade enemy reconnaissance, delay artillery corrections, and allow armored units to reposition without immediate detection. Among these nations, the Soviets took the concept furthest. Their theory of deep operations demanded rapid concentration, sudden thrusts, and continuous movement of reserves. That tempo depended on masking bridges, railheads, and artillery hubs from aerial observers. Between 1935 and 1940, the Red Army steadily expanded its chemical engineer arm, training battalions capable of laying continuous screens hundreds of meters wide, a capability unmatched elsewhere in Europe. Germany, meanwhile, channeled its resources into the offensive power of fast armored formations. Smoke was treated largely as a tool for assault pioneers clearing obstacles or covering short-range advances. The Wehrmacht never envisioned the strategic use of smoke to blind whole sectors of the battlefield. That doctrinal gap meant that when Europe rearmed in the late 1930s, the Soviets and Western allies were already refining mechanical generators able to blanket rivers, coasts, and armored corridors for hours at a time, an innovation that would soon redefine how entire operations were concealed as the war expanded. By the late 1930s, the machinery that would one day swallow entire horizons behind rolling walls of vapor was already emerging in workshops, proving grounds, and chemical engineer schools across Europe. In Britain, 1937 marked a quiet but pivotal milestone with the introduction of the Hood and Harvey smoke apparatus mounted on lorries. These systems injected titanium tetrachloride into airflow streams to produce dense, persistent clouds capable of covering roads, depots, and coastal sectors. Their steady output and mechanical reliability signaled that smoke no longer belonged solely to infantry grenades or engineer pots. It was becoming an industrial tool scaled for modern war. Across the Soviet Union, development accelerated even faster. In 1938, the Red Army unveiled the TDP-3 smoke generator, a robust machine designed for continuous screening along fronts measured in hundreds of meters. Mounted on ZIS trucks or fitted to riverboats, a single TDP-3 could run for more than an hour without pause, filling valleys, fields, or sections of riverbank with thick white vapor. Complementing these heavy units were the ROKS-1 and ROKS-2 backpack projectors, compact devices carried by trained chemical engineer teams. To German soldiers, they resembled flamethrowers, yet instead of fire they produced rapid billows of hot smoke that could seal gaps in larger screens or envelope an infantry platoon during withdrawal. Soviet engineers spent the late 1930s mastering techniques for layering smoke in humid conditions, adjusting chemical mixtures so the vapor clung low to the ground and resisted dispersal by wind. German intelligence tracked these developments, noting the new equipment but assuming it would be restricted to river crossing or point defense tasks. The possibility that such machines could mask entire regiments or reshape operational visibility was broadly dismissed, but by 1939-1940, as production increased and chemical engineer battalions expanded, these systems began appearing in larger numbers. Their output was no longer calculated in meters but in kilometers, laying the mechanical groundwork for the vast screens that would soon confound advancing troops. With these devices in place, smoke was poised to shift from a tactical aid to a tool of operational deception, setting the stage for its first battlefield-wide employment, the first clear demonstration of how modern smoke technology could reshape an entire battlefield emerged in the frozen forests and fortifications of the Winter War, fought between the Soviet Union and Finland from November 1939 to March 1940. Along the Mannerheim Line, an interlocking system of trenches, anti-tank ditches, bunkers, and forest obstacles, the Red Army confronted defensive works ideally suited to Finnish troops, who knew every contour of the terrain. As Soviet assaults stalled through December, chemical engineer battalions were pushed forward with an increasingly central mission to blind Finnish observation long enough for sappers to reach the obstacles that held up entire divisions. On the 1st of January 1940, during renewed Soviet pressure around Suma, this approach was displayed on an unprecedented scale. TDP-3 generators mounted on trucks rumbled into sheltered positions behind the front and began pouring out continuous waves of white smoke that rolled over the snowfields. Like low clouds, sappers advancing toward reinforced bunkers found their movements masked. As the haze spread over anti-tank ditches and wire entanglements, Soviet tank crews, attempting to force the Finnish lines, used this same cover to approach choke points that had previously been death traps for armor. Under direct observation, Finnish artillery spotters reported that sectors hundreds of meters wide simply vanished for hours at a time, leaving them unable to track Soviet preparations until the final moments of each assault. Although Soviet infantry paid a steep price throughout the campaign, the effectiveness of these smoke operations was undeniable. German military attaches in Helsinki recorded the unnatural density and unusual persistence of the Soviet screens, noting their adaptability even in sub-zero conditions that might have dispersed lesser mixtures. Their reports would later surface in 1941, though the OKH largely dismissed them at the time. In the Winter War, the Red Army discovered that smoke could crack open the tempo of fortified battles, blunting enemy vision and enabling maneuvers impossible under clear skies. As tensions between Germany and the Soviet Union sharpened in 1940-41, these lessons crystallized into doctrine, preparing the Soviets to wield smoke not only as tactical concealment but as an operational weapon. The full impact of that preparation would confront the Wehrmacht in the opening hours of BARBAROSSA. Dawn on the 22nd of June 1941 brought not only the thunder of artillery and the roar of engines, but something far more disorienting for the men of Army Group Center: the sudden disappearance of the battlefield itself. As German units surged across the frontier, the Soviets activated a network of chemical engineer brigades stationed along key axes, from the Pripyat marshes to the Dnieper line. Hundreds of TDP-3 generators, positioned in defilade near bridges, river crossings, and fortified belts, began releasing continuous streams of vapor that pooled in low ground and rose in thick, drifting waves. Thousands of rocks projectors added rapid bursts of denser smoke to seal gaps, the combined effect turning entire landscapes into shifting plains of white. Near Brest-Litovsk, screens laid by the 2nd Separate Chemical Battalion concealed retreating rifle regiments and masked the repositioning of anti-tank batteries, which German reconnaissance elements reported simply disappeared the moment the smoke settled across the fields. As the morning widened into midday, German formations advancing toward Orsha and Mogilev found Soviet withdrawal routes completely blanketed. Artillery regiments that should have been trapped under Luftwaffe observation slipped away with minimal losses because pilots circling overhead saw only a seamless canopy of smoke stretching for kilometers. On the ground, panzer crews accustomed to dominating with long-range optics watched their periscopes drown in white vapor. Gunners worked their elevation wheels in frustration, unable to fix targets beyond a few dozen meters. Compass bearings replaced direct sight lines. Armored columns advanced in disjointed bounds. Wary of ambushes that never came, the psychological impact rippled through every level of command. Some battalions radioed that they might be facing chemical agents, prompting requests for Nebeltruppen specialists. Luftwaffe crews, deprived of visual reconnaissance, reported increasing anxiety as operational timing faltered. For the first time in the war, German speed, precision, and confidence were not checked by enemy fire, but by the unsettling reality of invisibility. In the weeks that followed, as Soviet forces repeated these vast screenings along the Dnieper and in the approaches to Smolensk, German intelligence began assembling reports to explain how whole fronts could simply vanish. Those assessments would become the basis for the Wehrmacht's first serious study of Soviet smoke doctrine and inquiry. That forms the bridge to the next stage of the story. In the aftermath of Barbarossa's opening shock, the Wehrmacht struggled to understand how the Red Army had made whole sectors of the front vanish. By early July 1941, intelligence officers from Fremdheer Ost and the Chemical Warfare Service were receiving a flood of frontline reports that contradicted one another and revealed the extent of German confusion. Infantry companies submitted rough sketches of truck-mounted devices glimpsed through the haze, identifying them alternately as flamethrowers, fumigation machines, or chemical sprayers. Some battalion staffs insisted the Soviets must have captured German Nebelgrit during earlier border clashes and repurposed them. Other units claimed the smoke was being produced through improvised fuel fires in trenches, a theory that dramatically underestimated the mechanical sophistication of equipment like the TDP-3. The uncertainty deepened as Panzer commanders filed complaints that Soviet smoke persisted far longer than the output from German smoke pots or assault pioneer devices. The lingering screens, especially round river crossings, prompted speculation that the Soviets might be using unfamiliar chemical compounds. Luftwaffe crews added their own concerns. Reconnaissance pilots, accustomed to controlling the skies with confident visual surveys, reported that even low-altitude passes could not pierce the layered haze covering Soviet withdrawal routes. Some airmen warned that the smoke was disrupting the timing of close air support, leaving attack formations to search blindly for targets. Interrogations of Soviet prisoners gradually chipped away at the mystery. Captured chemical engineer troops described specialized schools dating back to 1935, and battalions trained specifically to deploy smoke at the operational level. These revelations startled German analysts who had long regarded Soviet support units as poorly developed. Now, officers across several commands began to fear that the Red Army could mask entire divisions or maneuver artillery with near impunity whenever conditions allowed. By late 1941, these intelligence reactions were shaping German tactical responses, forcing the Wehrmacht to reconsider assumptions about Soviet technological backwardness. Yet as both sides accelerated wartime production, a larger transformation was already underway. Industrial-scale manufacturing of smoke equipment that would empower the vast screens of 1942 In 1943, that escalation marked the next phase in the evolution of battlefield concealment. By early 1942, the scale of smoke production across the Allied world had entered a new phase, one driven not by improvisation at the front, but by the full force of wartime industry. In the Soviet Union, entire manufacturing lines were shifted east of the Urals after the Great Evacuations of 1941, allowing factories to resume output far from German bombers. These plants produced thousands of TDP-3 generators annually, each capable of laying continuous screens along riverbanks or defensive corridors. Alongside them, smaller ROX backpack projectors rolled off assembly lines in astonishing numbers. By 1940 to 1943, production exceeded 20,000 units, providing frontline chemical engineer battalions with a flexible tool that infantry and sappers could use to extend or reinforce larger screens. The chemicals that fueled these devices, most critically titanium tetrachloride, were delivered in quantities unimaginable before the war. As Soviet chemical plants ramped up distillation and refinement to meet operational demand, Britain, facing its own global commitments, pursued a similar industrial expansion. The introduction of the Universal Smoke Candle USC provided armored brigades, preparing for operations in North Africa with a lightweight but potent screening tool. At the same time, improved hood-type generators were mounted on vehicles designated for large-scale operations, their output optimized for open desert terrain where the absence of natural cover made concealment indispensable. To sustain these systems, British Chemical Works increased production of sulfur trioxide chlorosulfonic mixtures, designed to produce dense, long-lasting vapor that lingered even in dry, wind-swept climates. By mid-1942, British commanders could request miles of screening in advance, confident the factories at home could replenish stocks as quickly as they were consumed. German intelligence took note of this industrial surge. Reports forwarded to the OKH warned that Allied and Soviet supply chains now supported continuous, large-area screening in a way the Wehrmacht could not match. German Nebeltruppen remained constrained by limited generator stocks and the finite supply of ammunition-based smoke rounds. The contrast revealed a deeper shift. Smoke was no longer a supplementary tool, but a component of operational planning, integrated into assaults, retreats, and force concentration. As these production lines matured, future battles from the Volga to the Libyan desert would unfold under skies repeatedly veiled by engineered fog. And in North Africa, the British Eighth Army would soon use this new abundance to alter the geometry of mobile warfare. Catching the Axis by surprise once again, the Western Desert, with its flat horizons and near absence of natural cover, became the ideal proving ground for the next great evolution in battlefield smoke. By late 1942, British and Commonwealth forces preparing for the Second Battle of El Alamein understood that concealment was not merely an aid to maneuver, but a prerequisite for breaking the Axis defensive system. When Montgomery launched Operation Lightfoot on the 23rd of October, the assault opened not only with artillery fire, but with an immense, coordinated curtain of vapor. Hundreds of universal smoke candles ignited across the northern corridor, while truck-mounted generators pushed out continuous clouds that spread across wadis, minefields, and assembly routes. What might have been clear avenues of fire the day before turned into rolling white walls that stretched for miles, denying the defenders any precise sense of British deployment. Axis reports captured the magnitude of this shock. Forward anti-tank crews from the 15th Panzer Division recorded that British infantry emerged from the screen only when they were within grenade range, leaving German gunners unable to exploit the long-range accuracy that had been a hallmark of their 88mm guns. Italian batteries positioned along likely approach routes watched their sectors dissolve into uniform haze, firing only at guessed coordinates. In the air, Luftwaffe pilots attempting to disrupt British artillery concentrations found themselves flying over cotton-like oceans of white, with gun flashes invisible and supply columns masked from view. Bombing runs became speculative, carried out on approximate timing rather than visual confirmation. Rommel would later write that British smoke had taken the eyes from our guns. nullifying advantages the Afrika Korps relied upon in open terrain. The psychological effect was no less significant. Many Axis soldiers described the eerie sensation of enemy everywhere, enemy nowhere, as if the desert itself had swallowed the Allied armies until the moment they chose to appear. The success of these operations revealed how, in a theater defined by visibility, the deliberate removal of sight could determine the tempo and outcome of battle. The lessons of El Alamein did not remain in the desert. They reached eastward, where the Red Army was preparing to apply similar principles on a far larger scale across rivers, factories, and ruined districts in the crucible of Stalingrad and the operations that followed. The transformation of smoke from tactical aid to operational instrument reached its fullest expression on the Eastern Front between late 1942 and 1943, during the Soviet counteroffensive at Stalingrad. Concealment became essential to the timing and concentration that defined Operation Uranus. In the early hours of the 19th of November 1942, chemical engineer battalions deployed along the Don and Valda began releasing dense screens that drifted across assembly areas where artillery regiments were massing for the opening barrage. Battery commanders reported that the smoke allowed them to move guns into final firing positions without alerting German observation posts. On Mamayev Kurgan, the vantage point that had served 6th Army spotters for months, observers watched Soviet lines vanish entirely during the critical hours before the assault. The disappearance masked not only troop movement, but the expanding scale of the Soviet buildup, contributing to the surprise that allowed the encirclement to unfold. As the initiative shifted westward in 1943, smoke took on an even broader role in operational maneuvers, particularly at major river barriers. During the Battle of the Dnieper in September, Soviet fronts staged one of the largest crossing operations of the war. To protect pontoon bridge construction and ferry traffic, commanders ordered the deployment of more than 1,000 smoke candles and numerous TDP-3 generators positioned along the eastern banks. These devices produced continuous white curtains that clung to the water and shoreline, obscuring the locations where the first waves of assault boats pushed off. Panzer Grenadier formations defending the western bank complained that Soviet boats appeared only in the final seconds of their approach, making accurate small arms or anti-tank fire nearly impossible. In the air, Luftwaffe dive bombers circling the river found themselves deprived of every visual cue needed to strike bridging equipment, forced to bomb through unbroken haze. They achieved only scattered hits while Soviet engineers established multiple footholds across the river. German diaries from this period captured the growing sense of frustration, a feeling of contending with an opponent who could hide the horizon itself for the Red Army. These experiences confirmed that smoke enabled not just concealment, but misdirection. Finds could be staged under cover, real crossings shielded from view, and the enemy's deployment distorted in the moments preceding an attack. By mid-1943, Soviet commanders viewed smoke as indispensable for any major offensive, a conviction that would shape the planning for their greatest set-piece operation of the war, Kursk. In the summer of 1943, the vast salient around Kursk became the arena in which smoke fully entered the era of industrialized, layered warfare. In the days leading up to the German offensive, Soviet commanders worked relentlessly to conceal the density of their defensive preparations. Chemical engineer detachments moved along forest tracks and sunken roads to release controlled screens that drifted over reserve assembly areas, artillery parks, and the rear edges of the first defensive belt. These screens obscured the movement of batteries shifting into final firing positions and masked the arrival of fresh anti-tank brigades intended to stiffen the second line. To German aerial reconnaissance, the Soviet depth appeared thinner than it truly was, its vital nodes hidden beneath slow-moving banks of smoke that spread evenly across the steppe. When the German 9th Army struck on the 5th of July, the Soviets intensified these efforts. Chemical engineer units positioned behind vulnerable sectors released rapid screens to cover the repositioning of anti-tank guns and self-propelled batteries responding to breakthroughs. Reports from 47 Panzer Corps complained that the smoke robbed attacking units of the long-range visibility essential for coordinated armored thrusts. Panzer crews found themselves advancing into constricted corridors, where they could not gauge the flanking ground until Soviet gunners opened fire. At several points north of Ponary, tanks were forced through narrow gaps because the surrounding fields were lost behind controlled haze, turning what should have been open maneuver space into a set of deadly choke points. After Kursk, smoke assumed an even larger role as the Red Army shifted into full offensive tempo in 1944. During the Vistula crossings of Operation Bagration, Soviet fronts deployed massive arrays of smoke candles and generator units to shield entire riverbanks. German defenders watched the eastern shore vanish behind white walls that lingered for hours, disrupting artillery observation and delaying the timing of counterattacks. For units already worn down by months of retreat, the inability to see the enemy contributed to an escalating sense of inevitability. Smoke no longer merely hit assaults, it shaped morale, eroded cohesion, and amplified the psychological weight of fighting an opponent who could render himself invisible at will. By mid-1944, smoke had become a standard feature of major Allied planning across Europe. The lessons drawn from Kursk and the Vistula would soon be mirrored on the Western Front, as preparations for the invasion of Normandy embraced concealment on a continental scale. Dawn on the 6th of June 1944 broke under a man-made horizon. As the Western Allies began Operation Overlord, smoke played a decisive role from the first minutes of the assault. British and Canadian naval forces released long ribbons of floating smoke canisters that drifted across the Channel swells, forming pale corridors that shielded landing craft approaching Juno and Sword beaches. Naval generators aboard escort vessels poured additional vapor across the sea surface, disrupting the line of sight for German gun crews positioned in bunkers overlooking the approaches. To the defenders, accustomed to tracking silhouettes at long range, the Armada appeared and disappeared in shifting layers of haze, obscuring both numbers and direction. Once ashore, Allied engineers pushed smoke forward to isolate individual German strongpoints. By blanketing pillboxes and machine gun nests, they broke the interlocking fields of fire that had been designed to sweep the beaches. On several sectors, British assault teams advanced behind controlled screens that masked their movement between shingle banks, preventing German units from coordinating their positions or identifying where the next breach attempt would fall. As the front moved into Belgium and the Netherlands later in 1944, these tactics evolved into mobile formations. Sherman tanks fitted with smoke generator attachments laid protective corridors to screen infantry crossings and hide armored buildups, preparing to push through narrow dikes and canal lines. During the Maas and Scheldt operations in October and November 1944, the scale of these screens expanded once again. Amphibious and commando units clearing German pockets that controlled access to Antwerp advanced behind miles of vapor produced by British and Canadian chemical detachments. Coastal defenders, deprived of air support and radar, reported that the horizon dissolved into unbroken fog, leaving them blind to Allied staging areas until assault boats appeared at the last moment. This mastery reached its height in March 1945 during the Rhine crossings. Near Wesel, British forces deployed hundreds of smoke generators to veil pontoon bridges and ferry points. German artillery observers wrote with frustration that Allied troops operated inside a world of fog, moving men, tanks, and supplies across the river with minimal interference. Screens remained in place for hours at a time, denying the defenders both observation and the confidence needed to direct effective counterfire. These operations revealed how far the Western Allies had progressed from using smoke as sporadic cover to integrating it fully into amphibious assaults, engineering tasks, and river crossing doctrine. Yet even as victory approached, the lessons of 1944-45 pointed beyond the war itself, toward a post-war era in which smoke would become a core element of modern combined arms planning, rather than a temporary adaptation to wartime necessity. As the war staggered to its end in May 1945, many Axis soldiers who survived the long retreat across Europe carried with them memories, not only of fire and steel, but of absence of battlefields that vanished into engineered fog. What had once been dismissed as a primitive aid for engineers had evolved into a weapon of operational deception, psychological disruption, and strategic reach. From the forests of Belarus to the dunes of El Alamein and the river crossings of the Rhine, smoke reshaped the way armies conceived movement, defense, and surprise. German accounts from the final months repeatedly describe the unsettling sensation of facing an opponent who could choose invisibility at will. Companies holding river lines watched Soviet troops materialize from white voids. Gunners in Normandy recalled how Allied armor advanced only when the haze thinned enough to reveal muzzle flashes at close range. The enemy's ability to hide artillery, shift reserves, or mask entire sectors behind veils stretching for miles eroded the certainties on which German doctrine had relied. For the Soviets and Western allies, smoke became a symbol of ingenuity in an industrial war, a simple chemical reaction scaled into a strategic instrument that could frustrate reconnaissance, neutralize long-range firepower, and disrupt the cohesion of defending units. After 1945, militaries across the world studied these lessons, recognizing that controlling visibility had become as decisive as controlling territory. Modern doctrines of concealment, counter-reconnaissance, and deception trace their origins to the vast screens laid across Europe, Africa, and Asia during the Second World War. And so the story circles back to that first shocking morning on the Eastern Front, when German troops advancing through the Bug River Valley saw the horizon swallowed whole. In that moment, they learned that even the air around them could become a weapon and invisible curtain that changed the nature of war itself.